Welcome to the Human 5.0 Project, the podcast where we cut straight to the breakthroughs that matter, the show where science meets self-optimization. I'm your host, Ultimate Biohacker 10X, and here we break down the real research, real data, and real dosing behind modern biohacking, from compounds and peptides to techniques, devices, lifestyle strategies, and performance protocols. Most people jump in and jump out before they get the gold, so we're keeping it tight and delivering the essential insights you need without the fluff. If you've taken the time to hit play, we'll make sure you walk away with valuable knowledge that can transform your approach to longevity, health optimization, and beyond.
Imagine this. Inside your body are cells that are supposed to die, but they don't. They stop dividing, they stop contributing, and they just sit there, broadcasting inflammatory signals like a broken radio tower. People call them zombie cells. Science calls them senescent cells. And here's the punchline. In animal models, clearing these cells can improve function across multiple tissues, like flipping biology from decline back toward repair. So today we're breaking this down raw. What senescent cells are, why they build up, how Senolytics work, what human trials show, and where the hype ends and the real science begins. Hey loyalists, biohackers, and longevity rebels, Ultimate Biohacker 10X back on the mic. We're here to optimize performance, extend health span, and take out the cellular trash before it turns your tissues into an inflammatory landfill. Welcome back to the Human 5.0 Project, and today, Senolytics and the war on zombie cells. No fluff, no vendor ads, just clean data. This episode is for educational purposes only. Nothing here is medical advice. Senolytics include prescription drugs and investigational approaches with potential side effects, drug interactions, and unknown long-term risks. Do not self-experiment. If you're considering anything discussed today, talk to a qualified clinician, especially if you have a medical condition, take medications, or have a history of cancer. Now, let's jump in and clean this up. Senescent cells are damaged or stressed cells that hit a point where they stop dividing, often as a protective mechanism. This can happen after DNA damage, oxidative stress, telomere shortening, chemotherapy, radiation, chronic inflammation, basically life. This idea connects all the way back to the Hayflick limit, the classic finding that normal human cells only divide a finite number of times before they enter a non-dividing state. In your 20s and 30s, your immune system is better at cleaning up the worst of these. But as the decades stack, clearance drops, and senescent cells accumulate. And the real problem isn't just that they exist, it's what they secrete. Senescent cells release a cocktail called SASP, the senescence-associated secretory phenotype. Think inflammatory cytokines, chemokines, proteases, growth signals, basically a biochemical smoke alarm that never shuts off. That SASP can inflame surrounding tissue, disrupt stem cell function, promote fibrosis, impair regeneration, and push neighboring cells toward dysfunction. This is a major reason senescence is tied to age-related disease biology across all systems. So the metaphor is simple. Zombie cells don't just sit there, they recruit chaos. In youth, your immune system runs like a clean city. Senescent cells show up, cleanup crew removes them. With aging, it's like sanitation stops coming. Cells linger, spread inflammatory signals, and the whole system starts smelling like chronic inflammation. Now enter Senolytics, agents designed to selectively push senescent cells into apoptosis, meaning programmed cell death, while sparing healthy cells. The modern Senolytic story really ignites around 2015 when research identified senescent cells' apoptotic pathways, basically the survival wiring that these cells rely on to resist death. That work led to early senolytic candidates like dasatinib, which is a prescription cancer drug, quercetin, a flavonoid you've probably heard of, and later other compounds like fisetin, navitoclax, ABT263, and more. The key idea here is that senolytics are often hit and run. They're not daily forever, because once you've cleared out a chunk of senescent burden, you don't need constant dosing, at least in theory and in many of these research designs. Here's where we get honest, because everyone talks about zombie cells, but nobody talks about the garbage strike. The strongest senolytic data is still preclinical, animal models and mechanistic work, but human work does exist, and it's growing. A well-known early human report involved dasatinib and quercetin as a small clinical study context focused on feasibility and biological signals rather than miracle outcomes. More recently published in The Lancet, Senolytics have been explored in Alzheimer's disease in small, early-stage feasibility and safety-focused work. Again, not proof of cure, but proof that researchers can administer a senolytic regimen and measure biomarkers and CNS penetration questions. And on the clinical trial landscape side, there are ongoing efforts looking at senolytics in frailty in specific high-risk populations like adult survivors of childhood cancer, because they can show accelerated aging phenotypes earlier in life. So the truth in 2026 is human research is real, but early. Outcomes are mixed depending on condition, dosing, and how senescence burden is actually measured. And the field is still defining who benefits, how to measure it, and what safe means long term. Now, there is a huge limitation. Senescence is not a one marker. You don't just pull a single lab and declare zombie cell high level. Researchers use combinations of things like P16, P21 pathways, SA, beta-gal activity, SASP factors, tissue markers, functional outcomes, depending on the study. There are published efforts pushing for better standardization of how senescence is identified and reported, because right now measurement variability is one reason the public conversation gets messy quickly. Translation: if someone online says, "I cleared my senescent cells," the only correct response is, "How do you know and what did you measure?" Let's talk risk without fear-mongering. Senescence is not purely evil. In some contexts, senescence helps with tumor suppression and wound healing signaling, at least temporarily, so indiscriminate removal at the wrong time in the wrong person is not a game. And if we're talking prescription senolytics like oncology drugs, those have known side effect profiles. That's why clinical oversight matters. If you have active cancer or recent cancer history, uncontrolled chronic illness, immune suppression complex, medication stacks, this is not DIY territory. So here's a practical lens. Senolytics are exciting because they aim at root-level aging mechanism, accumulated dysfunctional cells, and inflammatory signaling. But the winning mindset this year is this: stay curious and trust, but verify. And don't confuse promising with proven. If you want to be ahead of the curve, the move is to track the fundamentals that correlate with health span, sleep quality, strength, waist-to-height ratio, fasting insulin, highly selective C-reactive protein, VO2 max trends, recovery, and cognition, because those are outcomes you can actually act on now. Zombie cells are real. Senolytics are real, but the story is still being written, trial by trial, biomarker by biomarker. If you want more, next we can do a follow-up episode on xenomorphics, the compounds that may quiet the SASP without killing cells, and how this fits with mitochondria, autophagy, and immune rejuvenation. So drop me a note and let me know if that's an interesting topic for you, and we will try to make that happen. Until then, clear out the zombies, stay sharp, stay vital, stay timeless, and I'm out.
Thanks for listening to the Human Upgrade Project. If you found value in today's episode, share it with someone who's ready to elevate their biology. Make sure to follow the show for weekly deep dives into peptides, protocols, devices, lifestyle strategies, and the science of high-performance longevity. Until next time, stay curious, stay optimized, and stay 10x